My theory is basically you can have space without time, but you can't have time without matter, okay? And during this theory, in researching it, I ran into Heisenberg, okay? And it signifies to me that he knew more than Einstein did. But it's easier to ignore him because there are factors that we can't measure, okay? So we just go ahead and say, oh, it didn't exist. And the thing is, it's only a matter of time. And it's the saying, a matter of time is the whole idea here. Only time and matter, or matter and time, are symbiotic. Space and time are not symbiotic. Okay, first of all, you can't measure space, okay, because there's no beginning and no end. It's timeless. Therefore, you can't measure it. The uncertainty principle, okay? You also can't measure the position, the velocity of the Big Bang, or the singularity, okay? So we can't measure that. We can't even apply time or anything to it, okay? Now get this. The area around the Big Bang had to exist, okay? The singularity, the area had to exist, okay? Existence for it had to exist, therefore it couldn't have existed. That's just, it's as easy as that, okay? Space had to exist first, okay? Imagine space is this page. How could I draw this little circle for a singularity if there's no page for me to draw it on? Draw it in the air, you know? So, technically, something had to exist for the Big Bang to exist. That means space existed, all right? This is the zero-point energy that Heisenberg was talking about, okay? This also lends more credibility to Heisenberg. It's signifying that he was right, not Einstein. And like I said, it's a matter of time. Okay, now, zero-point energy. You have these energy fluxes, all right? This energy that wants to come into existence, but it'll bleep out, okay? There's energy here, all right? What's this energy going to do? It's going to want to form the most simple and abundant element that it can possibly form, and a bunch of it, okay? It's going to be a simple, abundant element, atomic hydrogen, okay? Now, in space, there is no relativity. All right, because you have nothing else relative to it. Now, I can understand why somebody says, oh, well, space and time are relevant. They have to exist with each other, okay? Well, first of all, time is a measurement. You cannot time space, okay? I understand you're saying that there's an area there for that space and some time there, but that only applies if you have a watch and you go into space and you start measuring it. 1, 2, 3, 4. Then bleep out of existence. Technically, everything that exists only existed for 4 seconds, okay? So time can't apply. Only when you go in there with a clock or a watch can it apply, okay? So only the space can be measured as space. You can't even measure, you can't even quantify space, all right? And this is more of Heisenberg, okay? You cannot quantify space, okay? And the Riemann's paradox, infinity minus infinity, what are you going to have? Literally, like I was saying, you can't take space away from space, all right? So this can't happen. You can't have an edge of the space. And if you did have an edge, what's on the outside of the edge? What, more space? You know? I mean, space is infinite. Okay, now if you have this zero-point energy, it's going to want to come into just a simple element. It's going to want to form, due to no relativity, into space. This can be tiny. This could be bigger than our solar system. Okay, this could be bigger than our galaxy. But in comparison to space, see, these are little filaments. This right here could be trillions of miles away from this one, but technically on a grand scale of space, it's only right beside it. Like on this page, it's only less than an inch apart. You know what I'm saying? So so technically, you have no time, which is no relativity to time, because you can't measure it, because there's no beginning and no end. And size is irrelevant too, because it's space. You can't compare it, right? You can't get any comparison there. You can't get a measurement at all, okay? So you have the Heisenberg zero-point field. You have Heisenberg's energy, basically. And then you have the fact that you can't measure this stuff, the uncertainty principle. Okay, so it all forms, and it comes into a big bang. Boom! Now we have a bang. Now we can measure time. 13.7 billion years, all right? During this time, all this pure hydrogen that formed this big bang formed more hydrogen, helium, and lithium, okay? The characteristics of hydrogen, helium, and lithium are very special, like lithium being very reactive, okay? Helium having a very low melting point and very high boiling point, which is absolutely zero, basically. And helium being the most simple and abundant element in the universe, okay? You have 2 gases that have special properties and 1 metal that has special properties. And when you add up their atomic numbers and everything, basically, you get 6, which is carbon, us, carbon-based life forms in the universe, okay? This simple bang is ash. Everything in the universe that's living is ash. Everything is basically ash. So, this also brings the Big Crunch into perspective, and multiple Big Bang Theory into perspective. Now, like I was saying, this whole universe here, this little dot, you know, could be huge, but it's tiny because there's no relativity, okay? Now, when you have everything in space that slows down, simply because this stuff is trillions of miles, it's really close. Once it loses all of its dark energy and momentum, it's going to end up coalescing, just like a star does, just like a protostar. When hydrogen coalesces and forms a star, then elements and rocks and everything forms around those to perform, unity for a solar system, okay? It coalesces into a solar system. So basically this stuff is going to recoalesce back into another singularity and explode again, like a Big Bang, okay? Or a supernova or interstellar star. Now there's technically nothing new in the universe. Everything just has different scales. And this is the original largest scale. But it's very simple and it makes perfect sense. And it coincides with a lot of Heisenberg's theories. Okay, so I think he was working on the Big Bang, and this basically proves that he was more correct than Einstein was. But we go for Einstein, we lean toward him more because we don't understand Heisenberg's, okay? But it's easy to just say, God did it, just like, but literally all this does is proves that Heisenberg was a lot closer. He was more on track than Einstein ever was, and we lean towards Einstein. We always do the exact opposite of what we're supposed to do. What is up with that? What is up with doing the exact wrong thing? It makes no damn sense. If we want to understand something, how about getting our heads out of our asses, into the air a little bit more, and start actually acknowledging things? And quit with this cognitive dissonance, okay? Oh, it's new information. Oh, it's something that I don't understand. Oh, well, it ain't real. I mean, come on, get the shit together. It's not hard to understand that first you have to have existence. You have to have existence for this singularity to exist. It starts there. It's very simple. It doesn't get any more technical than that. You have to have existence for existence to be. That's as simple as it gets. Heisenberg was right. Einstein was wrong. It's a matter of time. Space, comma, matter, and time. Okay? These two are symbiotic. Space is a Lone Ranger.